Oracles and escrows, smart contracts on Bitcoin and Lightning. Let's do some definitions first. An oracle is a service that triggers a Bitcoin payment based on the outcome of a real-world event. And oracles are pretty cool because they allow you to do a lot of different smart contracty things on Bitcoin. An escrow is a similar service. It is when it's actually a type of oracle, but it is a service that is relied upon by two parties to settle or cancel a payment between them in case they have a dispute. And I say an escrow is a type of oracle because they are triggering a payment. Let's say you have Alice and Bob, and they have an escrow between them about whether a product is getting delivered. The trigger for the payment is like, did Alice get her product? And then if that happens, Bob gets his payment. So an escrow is a type of oracle that is mainly used for trades. And then an oracle is like a more general term for any service that triggers a Bitcoin payment based on a real world event. Oracles are important because Bitcoin and the Lightning Network don't know what happens in our world. They only know what happens on their networks. For example, let's say you wanted to bet on the Super Bowl. Bitcoin doesn't know about the Super Bowl. It has no idea the Super Bowl is a thing. All it knows is hashes and numbers and elliptic curves. It's like, I don't know what a Green Bay Packers is. So they have no way of knowing if who won the Super Bowl. So how do you bet on that? Well, you use an oracle. Suppose the two people, Alice and Bob, want to bet on the outcome of the 2020 Super Bowl. They each want to put up $100 and then have the winner get the pot. An oracle is someone who they both trust. This is a trusted situation here, to write the correct result somewhere, and then they can create a Bitcoin transaction that says, if the oracle says Team A won, then Alice gets the money. Otherwise, Bob gets the money. And it's important that the oracle writes this stuff in a way that Bitcoin can understand, because Bitcoin only knows hashes and time locks and signatures and stuff. So you got to write these contracts in a way that Bitcoin can understand. And the oracle's word then triggers a payment of money from one party to the other. Escrows are similar. You use them to dispute a payment if there is a dispute. They're often used in an eBay-like context, like Alice is selling something on eBay. Bob wants to buy it, but Bob's like, what happens if I send my money and she never sends me the watch? And Alice is like, well, I'm not going to send you the watch unless you send me the money, because then you may just run off with it. So they don't trust each other. But if they both trust the oracle or the escrow, they can give the money to him, is what they usually do. And then he can listen to what happens. And if they're both like, okay, I got the watch, and the other guy's like, I got the money, or if Alice says I got the watch, then the oracle or the escrow can give Bob the money, or vice versa. If there's a dispute, then he can listen to both sides and be like, okay, Alice, what happened? And she's like, well, he never sent the watch, or he sent a box of rocks or whatever. And then they can have a dispute, and he can decide who to side with. Usually it's done in Bitcoin with a type of Bitcoin address called a 2 of 3 address, because in Bitcoin we don't like, or many people don't like taking custody of people's Bitcoins. And so there are services that offer escrow without taking custody. And how they do it is they use 2 of 3 addresses. A 2 of 3 address is a special type of Bitcoin address that has 3 private keys. It's protected by 3 different private keys. And you need 2 of them to move any money that's in the address. So you set up this contract where one private key is held by Alice, one's held by Bob, one's held by the escrow. Bob can put money into the address, and then if he gets his product, he sends his key to Alice, and now she has 2 of the 3 keys, and she can withdraw the money. But if there's a dispute, either of them can ask the escrow to settle the dispute, and the escrow can listen to both sides and then send their 3rd key to whoever they think is the victim. Now that person has 2 of the 3 keys, and so they can withdraw the money. These can both be used on Bitcoin and the Lightning Network to enable various smart contracts without giving up custody of your Bitcoins, which is great because I like to keep my Bitcoins. You can create contracts with other people that rely on an oracle to provide information that triggers a payment from one party to the other. This is useful for gambling. Today, I'm going to actually demo a coinflip contract that I wrote using Lightning Escrow. And then you can also use an escrow to settle any dispute you have in a loan contract or a contract where the 2 parties trade something with one another. All right, so that is a hopefully quick-ish overview of how of what these terms mean, oracles and escrows. And then in this slideshow, which is shorter, I show how we do it. This is how we brought this to the Lightning Network, where we don't have such things as 2 of 3 multisig, but what we do have are HTLCs. So every Lightning payment, this is a standard Lightning payment, works like this. Alice creates a hash time lock contract in her Lightning node with these terms. Bob can take Alice's sats if he discloses a pre-image, or Alice gets it back after 2 weeks. She gets her money back after 2 weeks. And so I represent this here by having a picture of Alice sending a Bitcoin payment to Bob, who's holding this thing called a pre-image. And she says, give me a receipt or I get my sats back. The pre-image serves as a sort of receipt here. So they basically do a swap. He gives the pre-image, and at the same moment, he acquires control of the sats. And when he does that, he's like, all right, here's your receipt. Now I've got the money. And she's like, sweet, I can use this to show that you're supposed to send me a widget or whatever. So that allows Bob to simultaneously acquire full power over the sats after he gives Alice a receipt. But Alice, all she's got is a piece of text at this point. She doesn't actually have the watch or whatever she's buying from Bob. So what if Alice is like, okay, I have the text, but the watch never arrived, or she's worried that might happen. This is what we do to add an escrow into this situation. We create the pre-image. This is us down here at the bottom. Lightning Escrow creates the pre-image for this contract, and then Alice creates the HTLC that says, okay, if you give me the pre-image, Bob, you get the sats. But now, no matter how many tries Alice attempts to send this payment, Bob can't settle it because he doesn't have the pre-image. Like, he's got to give her the receipt, and he doesn't have it. Lightning Escrow has it. So Alice can be sure that the payment's not going to go through without Lightning Escrow's help. So in the happy path, Alice and Bob have no dispute. We give Bob his pre-image, and then he gives that to Alice, which simultaneously gets him the sats that he needs. Or if there's a dispute, there's a time lock on these contracts. That's what HTLCs do. If we side with Alice, then we just let the transaction time out, which is represented by the alarm clock here and the unhappy faces. Alice didn't get her product. Bob didn't get his money, but at least no one is out any money. Alice keeps all of the money that she had in her wallet. So yeah, that is how we do this stuff. I also want to mention that Lightning Escrow offers a free developer API, and if you use this, you get full control over the escrow. You decide if Bob or Alice gets the money, and you decide what conditions to use. We have a demo API in both JavaScript, or not a demo API. We have a full API in JavaScript and Python. An API client. Like we already wrote the code for you. In case you want to just get started, you can copy the code from our JavaScript and Python client implementations. And this is fully programmable. You can write, you control everything. You control the Oracle. You control whether Bob or Alice gets the payment, and you do it all without taking custody of user funds. So it can be pretty cool. And I thought that I would just go through the API and show you how this works. First, I'm going to share this link. This is the documentation for the API. So I'm going to share this over here. So yeah, that's where you can follow along with this. And there's also a video demo of me doing this thing that I'm about to do with you guys. So we've got a bunch of endpoints. One of them is for creating a user, and I'm just going to copy paste this code into CodePen, where I'm going to run it, and I'm going to create a user. Let's give him an email. Doesn't have to be a real email. This is just used to authenticate whoever's in control of this contract. So I'm going to do, I don't know, President Johnson at example.com. He's going to use the password Hunter12 because that is the best password ever. And when I do that, I get a session ID and an expiry. So he's logged in effectively, and his login will last for 2 weeks. We set a limit of 2 weeks because it's standard security practice that you log people out after 2 weeks. If you're a developer and you set a better password than 112, you can extend your session key, which I will do down here. Extend your session key, and that will set it so that it doesn't expire until the year 2031. So to do that, you just paste this code over here, or we also have the Python version. Replace the demo one with your real session ID and hit enter. And now your session lasts until the year 2038. So you can have lots of contracts. Let's create a transaction here. It needs a bunch of parameters. and let me go over what those are. So the first thing it needs is your session key. This is the session key of you, the Oracle, who's controlling this whole thing. You need to know who the buyer is. And this, again, doesn't have to be a real email. You can put in a fake one, however you want to display this to your users. If you do put in a real email, your user will get an email from us saying, hey, someone wants to do a transaction with you. Here's where you can click a link to do it with them, and it'll take them to our front-end interface. But I'm going to use another president. President Bush at example.com is going to be buying the goods. We're going to sell him some pizza, and we're going to do a large pepperoni. He's going to pay. You can decide who pays the fee. Like I said, it's a free API. We haven't implemented fees yet, and so you get to use this for free. But there's going to be an amount of 5,000 sats on this thing because it's not a great pizza, I guess. And I even spelled pepperoni wrong. All right, so let's hit enter on there. And when I do that, I get a, didn't want to do that, cancel, don't print it. I get information about this transaction, including a transaction ID, which is ID number 4, and a description of it. I get the amount of it. I can see who the seller is. The seller is person number 3, or it has ID number 3 in our database. It's me. And I get a payment hash. So here at this point, you need to have your user, or you need like their macaroon or something, so you can create an invoice for them. And I'm going to do that in my terminal here. Add hold invoice with this payment hash, and the amount is going to be 5,000. All right, so I got this invoice, and we're going to use that in the next section. So here we go down to creating the invoice. This is all for getting information about individual transactions or all transactions, which you can use if you want to display like a dashboard to your users. But down here, I'm going to send in the invoice that I just created. So I go to CodePen, paste this in, get my invoice from the terminal, copy that, put that in here. And what was the control X? What was the transaction ID? Backspace isn't working for me. Do that. Oops, I forget what my transaction ID was. Well, I can figure it out again by looking up my transactions. So that's cool. I will just go and re-log in to get my session ID, and then I will look for my most recent transaction. So copy that, go to CodePen, Control paste, and I believe I was President Johnson. So hit enter. This is my session key. I'm going to get my transactions, which is down here. Get all user transactions sounds good. Copy that. Paste it. Unfortunately, I can't see. Oh, there it is. My session ID. So paste that in, hit enter, and now I find that my transaction ID number was 4. So that is what I'm going to use when I create my invoice. I'm going to copy this, paste it into here, and my session ID is, man, can't remember anything. Session ID was this one. Paste. And my transaction ID was number 4. And my invoice was this one. Paste. Run this code. And great. Now the status of our transaction is that it needs to be paid. So I'm not actually going to pay this because it's just a demo and there's no reason to do that. But instead, what I'm going to do is I'm going to look up the status of the invoice on my node. So I do that using this command. LNCLI lookup invoice. And once again, this is something you need to do for your user after you get their macaroon, unless you want them to do it on their own node, which is on their own terminal, I suppose. But when I do this, it's going to tell me information about the status of the invoice. And currently, this invoice is in a state called open. The open state means no one has tried to pay it yet, and so the contract cannot proceed. But I'm going to pretend it's open because I'm the Oracle and I have full control over everything. I'm gonna pretend. I'm gonna pretend that somebody tried to pay it. Now, since this is a HODL invoice and this node right here doesn't have the pre-image, he can't settle the invoice. So instead of going into a state of settled, it will, if someone tries to pay this, it'll go into a state of accepted. And once it's in a state of accepted, that means it's like I've accepted this contract, but I can't settle it yet. I'm waiting for the pre-image so that I can, type it in and settle it and get the money. So that's what we're going to claim. That we're going to claim on behalf of Bob that the transaction has been put into a state of accepted so that we can continue the contract. But before we do that, we need to set a buyer. Or no, I already did set a buyer. So I did that before. So the buyer is going to claim the contract is funded. He's going to be like, all right, the person tried to pay the payment, and I can see that it's in a state of accepted. So that is what he is going to claim. Let me go get his session ID, which is this one. And the transaction ID is number 4. So here we go. Oh, I did something wrong because it is giving me an error. What is the matter with it? Buyer claims the contract is funded. Did I set the buyer? I don't think I did set the buyer, actually. It was President Johnson was going to be the buyer, and that's where I left off because I forgot who was in charge. So highlight all that, paste, and we're going to have it be President Johnson and transaction number 4. There we go. It says wrong password. I must have already put him in at some point. Oh, I was going to do President Bush. That's why. Well, I screwed something up during the process because nothing's working now. I think I ruined this contract. Anyway, the point is you can go through all these procedures. You can create a contract and then do a coin flip at the end or whatever you want. I was going to do a coin flip, but I apparently screwed everything up with this contract. So if I have time, I will redo it. Oh, okay. Well, I'm going to restart then because I'm not sure which part I screwed up in this thing. But I'm going to go back and create a new Oracle and do this whole process. I'm going to do John Davy is going to be the Oracle. I'm not going to extend the session key this time because we're going to definitely finish this within 2 weeks unless I have yet another error. Copy that, paste it in. My session key is, why can't I scroll? The difficulty with using, there are some difficulties with using CodePen and a Mac. I'm not usually on a Mac. Paste. This guy looks like a good person to be the recipient. We're going to sell him some pizza. Large pepperoni sounds good. 5,000. Enter. All right, we're using ID number 6 now, and this is our payment hash. So let's go create that invoice. LNCLI add hold invoice with a different payment hash now, which is this one. Paste it into there. Here it is. So now I go back to here and set the buyer. Oh, that's what I did. I never passed the invoice in on my previous one. I don't think I did anyway. trying to realize which step I skipped. Okay, so my ID is right here. Paste that. My invoice is right here. Paste that. And my transaction is 5. I think it's 5. Is it 5 or 6? It's 6. Okay. I'll hit enter. Great. So it got the invoice, needs to be paid. Next step is to set the buyer. So I need a name for the buyer. I'm going to use Rick Morty. Rick Morty will be the buyer. And this is going to be transaction number 6. Hit enter. No. Well, that function appears to be broken. I'm going to have the same person be the buyer and the seller. So John Davey, I think, was the seller. I actually recommend, if you are running the Oracle yourself, you probably should have the buyer and the seller be the same person. Yeah, John Davey at example.com, Hunter 12. You probably should have the Oracle be both buyer and seller in these contracts. And then you have control over whether Alice says she got the product or Bob says over what Alice and Bob say. So then you can like present buttons for your users to say like, I got the thing or I didn't or whatever. But anyway, so I do have a buyer now set, which is the same person as the seller. And I'm going to have the buyer claim that the transaction is funded. So he would do this only when his HTLC is in an accepted state, which you would find out using their macaroon. Copy this session, paste it into here. Transaction is number 6. When I do that, it tells me the status, which is that the buyer claims the thing has been paid. So I'm going to have the seller confirm that using this. All right, get my session ID, which is here. Copy, paste it. Transaction number is 6. So the status changes to where's status? Status is paid. This means the contract is funded, and now the HTLC is accepted, and now it is awaiting settlement. So the money hasn't changed hands yet, but all it needs to change hands is the pre-image. So first, we're going to make sure the goods get sent. So I'm going to claim on behalf of the seller that I shipped the goods out. If you're doing digital goods, you'd probably do this immediately. So get my session ID, paste that. These are something that you would store as variables in your user session normally. I am just copy pasting them from the previous entry. The status changed to the goods were sent. So next one is buyer confirms they received the goods. Here we go. Get my session ID from this one. Copy that. Paste it. Transaction number 6. Hit enter. Great. Goods received. At least he says the goods are received. So as far as Alice is concerned, everything is done now. And Bob is just waiting to receive the pre-image so he can get his money. Alice got her product, and she confirmed that when this command got run. Buyer confirms goods were received. So all that's left is to get the pre-image and settle the invoice. So this is where we're going to run the coin flip. I'm going to do math.floor, math.random times 2. And I think if I do that, it's going to give me a 0 or a 1. And we got a 0. So because I got a 0, that means Alice wins. And since she's the buyer in this case, so we're no longer doing pizza. I decided to switch it up to a coin flip now. But it's the same procedure basically. You have it's just with a coin flip, you would say the goods are received, quote unquote. If the player got if Alice guesses heads and the coin lands on heads here, then you'd say, okay, the goods were received, and you just wait for the contract to time out. And then if it landed on 1, then you run this function, which would give Bob his pre-image, and so that's what we would do then. But yeah, you can do anything with this. Like you have complete control over who gets the money, because if you give the pre-image to Bob, that means he gets the money, and if you don't give it to Bob, that means the contract will time out with our little alarm clock here, and Alice will get her money back. Well, and in this case, because it's a coin flip, she'd actually be happy because she won the coin flip. But if this was a goods and services situation, she'd be sad because, yeah, she got her money back, but she didn't get the thing she wanted, which is a pizza in this case. So let's just see what would happen if I had flipped 1, which I will do by, okay, now I flipped a 1, and we're going to pretend Bob wins, and I'm just going to show you what happens here. Copy this, paste it in, and let me go get the session ID right here, paste, and I'll make this this was 6, so I'll hit enter. And the last thing that happens is you'd send this JSON to Bob's client, or Bob's, you'd show him this pre-image, or you'd actually, probably with his macaroon, you just run this function, and the function is lncli settle invoice with this pre-image. When I run it, it's going to give me an error because no one ever tried to pay that invoice. But yeah, if someone had tried to pay it, he wouldn't have been able to settle it until he got this pre-image, and consequently, it would have been an escrow. But the neat thing is, all we're doing here, like you'll notice, we're not running a node or anything to run this procedure. All we're doing is generating a pre-image and then either giving it to him or not giving it to him. And so the only thing we need to run as a service is a random number generator. And then we never have the funds. It never passes through our node. We never have custody. We don't even have any Bitcoins on our server. The only thing that happens for us is like we get to pick: do we give the pre-image to him or do we withhold it? Because if we give it to him, he gets the money, and if we withhold it, the transaction cancels and she gets the money back. How could the Oracle know if a seller is dishonest? For example, someone wants to buy sats with an Amazon gift card, and the seller says the redeemer code wasn't valid. I don't know. What you could do there is you could ask Amazon. You could have some kind of partnership with Amazon where you say, was the redeem code valid? It's up to you. You're in control of how you tell if a seller is dishonest, because we don't take a part in that. We just leave it up to the developer to decide how to do it. Yeah, would the coin flip example work in a scenario with more than 2 participants, where each person could bet their desired number of sats? You could do it, but it would be really capital intensive. So on the Lightning Network, you only have 2 states of a payment. Either it went through to one recipient or it did not. And so if you wanted to do a coin flip between, like, I don't know, 5 people, what you'd have to do is you'd have to set up a payment to each of the 5 people. Like, let's say it was 1,000 sats. You'd have to send 1,000 sats. Each person would have to send 1,000 sats to every other player. And all of those would be escrowed, but only one of them would be settled. Like, only one person would get the pre-image and the others would all fail. So if you did that, yeah, you could do multiple participants. It would just be capital intensive because you'd have to put up 5 times, however many players there are, that times the bet amount is how much capital you'd have to put up.
And there's no other way around that, yeah?
Well, custody, if you want to do it non-custodial, that's the only way I know how to do it. You could also, we also have the base layer API. So like we do these things on the base layer as well, where there's no time limit. And one of the benefits of the base layer is that you can reduce the capital requirements. Like, everyone puts their money into this address, and then you give out the needed key to whichever participant is supposed to win. And then if you did that, you wouldn't take custody of funds because you only have one key, and you need, let's say it's a 5-person game, you need 5. But then you would give the remaining key to the person who is supposed to win. And if you did that, everyone would only have to put up however much the bet amount is, but it would be slower. It wouldn't be on Lightning. It would be more costly as well because there are transaction fees associated with that. But yeah, that is how you could do it
Okay.
with reduced capital requirements.
So many questions. I'm trying to figure out where to start. This, first of all, this was amazing. I think I think what you've built there has the possibility of opening like a whole new world of applications and stuff.
Yep.
The obvious one, obviously, you'd be like, oh, you want to do some like coin flip or like betting thing, but I think it gets like a lot more interesting when you start doing other kind of interactions like we've been looking at like some bounties, for instance. How can you use something like Lightning Escrow to set up bounties for this new platform that we're building, Bold Fund Makers platform? So maybe we could do another call so we could pick your brain. But we have one other question here. On the topic of random number generator. On the topic of a random number generator tool, can an Oracle also push a real-time market, like from a sports book for a particular game?
Yeah, you could. You could have the players bet on who's going to score next. And then if one side says Team A is going to score next, the Oracle would release the current score. And if that number is the one that increases, then that player gets the money. So yes, you could do real-time games for a particular game. Anything you can. So you as a programmer have full control over what the Oracle says, and if you want to do that, be my guest. It's free, and you can use it as long as you want, and we're not even charging fees. So go for it.
So I guess this works best for two-player games and in two players where both players are kind of like known, at least by the application, the service.
Right. Yeah.
Mhm.
The sportsbook service would best know who its players are. Well, they don't have to know their identities, but it does have to know their node pub keys, so it can send so it can detect that so that they can tell it. Hey, actually, no, it doesn't even need to know their node pub keys. Well, it needs to know the recipient's pub key, so that it can make sure the invoice, because you have to send it the invoice so that it can make sure the amount is correct and the payment hash is correct. Because if you didn't validate that, then the recipient might give an invoice that he has the pre-image for already, and then he could take the money immediately without the escrow. So you do have to give us the invoice, which means we learn the node pub key of the recipient. Yeah, but you don't need to know the sender, which is great because Lightning has sender privacy. And as long as you spin up a whole new node for each contract, you can even have a new pub key for each contract, which would be cool. Then we wouldn't even have to know the recipient. We would just know a random pub key each time.
So there's another one there. I see a use case in shipping. The shipper can act as the oracle, issuing the pre-image when the item ships.
Yeah, that's a cool idea. I've also heard somebody suggested once that you could have the buyer of the product come up with the pre-image, and they have to, let's say it's a pizza delivery, but you could do this for any delivery. When the delivery guy comes to the place, he has to hold out a device where they can type in the pre-image, and then that releases the funds to Pizza Hut or whoever's doing the delivery, and only then do they give the product over. So if you did it that way, where the buyer of the product is the one who creates the pre-image, that would be pretty sweet. We don't have that function built in. It's a really good suggestion. In our escrow, we always come up with the pre-image. But yeah, that's a super dope idea. And yeah, you can always write a contract where they hit a button that says, "All right, it arrived," and then and that's when we release the pre-image to the other person.
Man, I'm so excited about this. I am so pumped. Hopefully we could get you scheduled in sometime again this weekend. If you have time, we'll talk offline. And hopefully you stay around to do some mentorship if some people use the API and stuff in the Discord. But so many questions here, so many questions, and I'd love to do some brainstorming with you.